Imagine a vast city, not of steel and glass but of microscopic structures etched into silicon. Streets of copper interconnects stretch in perfect alignment, skyscrapers of transistors rise in dense clusters, and neighborhoods of logic blocks, memory banks and data pathways form the bustling lifeblood of computation. Now imagine that, instead of a team of human architects laboring for months to map this city, an artificial intelligence generates the entire blueprint in a matter of hours, and does it with a level of optimization beyond human reach. This is not a distant vision, it is happening now, and it is quietly rewriting the future of computing. If you want a front-row seat to the breakthroughs shaping our future, subscribe, like, and turn on notifications so you don't miss a moment. Inside Google's chip design labs, an AI known as AlphaChip has been given one of the hardest engineering problems on Earth. Place and route the organs of a modern processor so every signal travels the shortest feasible path, every watt of power is delivered cleanly, and every pocket of heat is tamed before it becomes a liability. AlphaChip does not write code or design software interfaces, it crafts the physical processors on which the most powerful AI systems will run, turning abstract intent into a layout that can be manufactured at nanometer scales. According to Google DeepMind, AlphaChip uses reinforcement learning, treating chip floor planning like an enormous puzzle where each macro block, memory tile, and interface must land in exactly the right location. The system learns by experience, running countless simulated layouts and rewarding itself when wire length shrinks, congestion eases, timing closes, and thermal balance improves. What would take a human team weeks or months can be produced in under 6 hours. And these are not toy designs. The resulting layouts have shipped in production across multiple generations of Google's tensor processing units, from V5e and V5p to Trillium and the latest, Ironwood. The measurable wins are not subtle. Google has reported shorter average interconnects versus human baselines and significantly better performance per watt generation over generation. In chip design, even a 1% gain can save millions and let processors run faster without overheating. A 6% improvement can turn a design that barely works into one that runs cool and reliably, powering data centers around the clock. Better physical design makes every digital experience smoother. Cloud services respond faster, recommendation feeds feel more instantaneous, and translation or voice assistants reply with less lag. Behind the scenes, data centers draw fewer megawatts for the same work, reducing costs and environmental impact. AlphaChip's speed changes the pace of innovation. When a floor plan takes months, teams avoid risks. When it arrives in hours, architects can test bold new ideas, bolder meshes, tighter memory clusters, or specialized compute blocks. That freedom yields better chips sooner, keeping hardware in step with the rapid evolution of AI. When power flows more smoothly and heat spreads evenly, chips last longer. That means laptops and phones stay cooler and quieter. Cars keep processing information even in summer heat. Hospital imaging machines can run non-stop without cooling breaks, a big deal when patient care is on the line. This faster cycle of experimentation doesn't just help big tech companies, it sparks creativity everywhere. Architects can take risks they once avoided, trying bold chip layouts that may unlock the next wave of AI breakthroughs. The result is a future where hardware evolves at the same speed as the software it supports. TSMC leads the foundry market and supplies chips to Apple, Nvidia, AMD, and many others, combining advanced processors with high-bandwidth memory, ultra-fast storage that keeps data flowing without bottlenecks. One packaging method, called CoWoS, stacks memory and processors closer together so information moves faster and wastes less energy. Samsung is pushing forward with a new kind of transistor called gate-all-around. Think of transistors as the tiny switches that let chips think. The older FinFET design controlled them from 3 sides, like holding something with a clamp. Samsung's new MBC FET design surrounds them completely, like a snug cuff. The result? Less wasted power, less heat, and chips that can keep shrinking while growing stronger. For everyday users, that means devices that run faster, stay cooler, and last longer on a charge. Tesla has announced a multi-billion-dollar deal with Samsung to build its AI-6 inference processor in Texas, aimed at real-time autonomy, robotics, and data centers. In parallel, Tesla uses TSMC for its AI-5 chip, spanning Taiwan to Arizona. This dual sourcing ensures progress continues even if disruptions occur. The quiet revolution continues in how chips are packaged. Performance depends on how quickly processors can talk to memory. By placing them closer together, data moves faster without extra chips. But stacking layers creates extra heat and power challenges. AI-assisted design arranges parts so the finished chip runs smoothly in the real world, not just in theory. Another big change is backside power delivery, sending electricity through the back of the chip instead of the front. This frees more space for signals to travel cleanly. The result, faster, smoother communication inside the chip. For consumers, that means quicker responses, lower energy use, and devices that stay smooth even under heavy workloads. These changes in packaging may sound small, but they transform what's possible. When every signal travels faster and with less interference, entire systems, from gaming consoles to self-driving cars, gain smoother, more reliable performance. It's the invisible upgrade that makes future experiences feel effortless. Phones gain real-time photo processing without draining batteries, laptops render video faster while fans whisper, AR glasses process more locally instead of relying on the cloud, cars see farther and react quicker even in hot conditions, appliances adapt to your routines without constant data uploads. Curious about machines designing the engines of tomorrow? Stick with us, subscribe, like, and turn on notifications so you don't miss what's next. Think of a data center as a giant digital engine, with thousands of processors working side by side. Even the smallest design gains add up when multiplied across these vast halls of machines. Just trimming a fraction of wasted power can save electricity on the scale of entire cities. In the data center, the gains multiply. A few percent power reduction per accelerator, multiplied by tens of thousands of servers, saves the energy of entire wind farms. Better layouts also mean more usable chips per wafer, lowering costs and boosting supply without new factories. Those savings ripple down to consumers, faster search, smarter photo libraries, and more capable assistants without skyrocketing prices. For consumers, this means search engines feel instant, voice assistants respond with less lag, and online tools like photo libraries organize memories with uncanny accuracy. The cloud feels faster not because of new apps, but because the chips running those apps are more efficient. There is resilience too. Faster design cycles and diversified fabrication across regions mean supply chains are less brittle. If one part is scarce, AI can quickly re-optimize layouts. Flexibility upstream means stability downstream for the products people rely on. This resilience doesn't just protect companies, it protects everyday life. A delayed chip shipment can ripple out into phone shortages, slower delivery of cars, or backlogs in medical equipment. By making chip design more adaptable, AI helps ensure that the technology people count on arrives on time. The research cadence benefits too. University teams and startups can explore novel accelerators when physical design no longer feels like a cliff. They can try unusual layouts or specialized engines, then get a manufacturable design by the end of the week. That is how ideas leap from whiteboards into silicon. This acceleration of research is what makes the future unpredictable in the best way. A university team today might test a wild new processor idea on Friday and have a working prototype design by Monday. That shortens the path from concept to creation dramatically. Skepticism has a role. Independent benchmarking and transparent testing keep claims honest. Experienced designers remain vital for setting specifications and ensuring safety margins. But the trend line is unmistakable. Machines are now competent at drawing the maps for the machines that think, see, and act, and each generation builds on the last. Each generation of AI-assisted design builds on the last. What seems groundbreaking today will feel ordinary tomorrow, and the cycle repeats faster with every step. That compounding progress is why we may see breakthroughs in the next 5 years that once seemed decades away. Every improvement at the silicon level eventually shows up in daily routines. Faster chips don't just help scientists and engineers, they shape how quickly your phone unlocks, how smooth your video calls are, and how long your battery lasts. For consumers, the bottom line is tangible. Snappier devices that last longer on a charge, quieter laptops, cameras that make night look like afternoon, home assistants that protect privacy, and vehicles that expand driver assistance into safer autonomy. Better chips make better experiences. These aren't abstract gains. A parent editing a school video, a commuter relying on GPS in heavy traffic, or a doctor pulling up patient scans all benefit when chips are faster, cooler, and more reliable. The technology fades into the background and the experience simply feels effortless. The world's infrastructure benefits as well. Smarter grids balance energy, warehouses route goods more efficiently, hospitals triage faster, and drones map disaster zones locally without cloud delays. And as these chips spread into global infrastructure, the stakes grow higher. A more efficient grid can mean fewer blackouts in summer heat waves. Smarter logistics can keep shelves stocked during supply chain crises. Faster medical devices can help save lives when every second counts. None of this diminishes the artistry of human engineers, it amplifies it. People still set the goals, write the models, and define the constraints. AlphaChip is a tool, a co-pilot, that helps navigate a landscape of trade-offs to find better answers quickly. The loop closes with a powerful truth. The AI interpreting a voice command, guiding a car, recommending a video, or helping a doctor spot a tumor is increasingly running on processors it helped design. Human creativity set the process in motion. Speed and scale now come from a partnership where learning systems draw silicon cities with growing mastery. Want to see the future unfold in real time? Subscribe, like, and turn on notifications. This is Tech Mythos.